Hello everyone, Shadow here from InfoSec. We've had another attack on our systems here, and we're going to dive into a multi-staged attack against our InfoSec server, so it should be fun. First thing we're going to take a look at is what our intrusion detection system had gotten from the offending IP address. So the first thing here we have is the post command, and this is the actual command that was attempted to be sent to our system. And we're going to decode this URL here presently. We can also see under here the user agent was spoofed, so it's basically saying that this attack's coming from an iPad or a Mac OS X-like system, which we know to be untrue. It's telling us what type of content was encoded here, and the content length, and then the connection close. Now, what's interesting here is the bottom line, where the attacker is attempting to have PHP itself execute a wget and download a script that would render the system inoperable, or at least render it exploitable. So let's describe this. PHP does execute system commands with proper precision. So what we have here is it's trying to get that script, it's trying to output it as a file to the location temp, okay, sh being the offending script. And then it's trying to run that script from the temp file and then remove it. Okay, so basically it's getting this script and then running it. So let's take a look at what the actual script is. The first thing of the script here is coming from this IP address. We know that it's a shell script. It's cding to the temp directory, and then again it's changing directories over to dev shm on the system. And then it's actually trying to get another file here, which is a binary or a compiled file, where we don't really know exactly what it's doing. We can tear it apart later with some hex editors and some disassembling programs, but for purposes of this application here, we're just going to look at what else it does. So once it CDs over to this directory, it tries to wget another file, which is RU, which is what we'll look at here in a minute, which is on the next attempt there. And then it also tries to get RR. This, in fact, isn't a usable address, so this comes up with page not found. So this is really irrelevant at this point. So let's take a look at what this first script, or this exploit code is trying to do. It's not really an exploit code at this point. It's just trying to take control of the system by killing certain kinds of processes. In this case, it's trying to kill all kinds of processes, and the important ones here we have is Apache and the web server and Perl and any other things that are attempting to run on the system is trying to kill them, you know, as we move down. And then the next part is interesting. If anybody's familiar with Linux, Linux has what's called a cron system. And what a cron system allows you to do is write certain commands into the system to be executed at given times. So what this is trying to do is write this into the cron weekly system. So this wget executes every week, and it's trying to download this same shell every week, run it, remove it, and then put it into the cron system. Okay, and then the cron tab command here, temp cron, puts this command, basically this whole command, into the cron system and then removes it to cover up its tracks. Okay, so let's take a look at the second attempt here, where this downloads the actual bin script and writes a couple functions here. The function run scan here, it basically changes directories over to the dev chm directory and chmods it to +x, making it executable, along with the other binary file it downloaded called php. Okay, so it's running those two as we speak if this were an exploitable system. The next thing that we have here is a function called is_pnscan_on. So it's basically checking to see if this system currently is running that exploit that was attempted. Okay, and it's returning a value if or if not. Okay, the next thing we have here is it's cding to the shm directory and checking whether or not this is a 64-bit system or a 32-bit system. Then what it does is untars this directory, meaning uncompress it, and then removes it. Okay, as we move down here, we have this other function. It's calling the function to see if it's running. If it's running, it's going to echo running back to the attacker, or not running back to the attacker, and then it removes both of those files. Okay, so it's basically running in a hidden way. And those two files basically were by this 64 directory, which I had downloaded, and these are the two binaries, along with this run program. Okay, so if we take a look at this, we can see just exactly what the run program is doing. It's taking those two programs, the PN scan, and running it against käⱧ and changing the HTTP header. I suggest you read onto that with a random IP address under 80. Okay, and then porting that over to infinity or null or whatnot in the background. You know, this little ampersand means it's running in the background. Okay, so we're basically getting a random IP address here and putting that into this variable. Okay, so that's basically what that does. We've seen quite a bit of this, and we're gonna take this code here, and once again we're gonna go over to our trusty not TextEd, but we're gonna go over to our trusty URL decoder here, and we're gonna see what that actually has to say when we decode it. And the same as before, it's simply trying to execute some parameters in the URL string that would be vulnerable to this attack. Okay, so we have a multi-staged attack, and what we have here is that we've looked up the CVE, which stands for Common Vulnerabilities Exposure, and it's a reference method for publicly known vulnerabilities. So you could look this up at yourself. So let's describe what this exploit was attempting to do. The CGI version of PHP has a main file called C here, which before this version and this version and this version, when PHP is configured as a CGI script, it doesn't properly handle the query strings. And what a query string is when you put something in the URL with question marks or, you know, fancy encoding, it doesn't parse the equal sign, which means it doesn't have to handle the equal character, which allows the attackers to execute the code, you know, by placing those commands. And what they're trying to do is execute the code that they had downloaded onto the system that they thought was exploitable. So the PHP get up for this case, I suggest you read this CVE version to see exactly what's going on. And that pretty much takes care of the exploit. It's a multi-staged exploit, meaning that it exploits the server then goes to the web, downloads certain scripts, puts them on the system, and then notifies the attacker of the multitude of programs that he or she was able to get running on the system. It's a little bit more complex, and it shows in the logs, and once again, as described last time, if you look into the logs, you can pretty much see anytime somebody's trying to exploit this because of the fancy URLs and the fancy encoding. So it's not that bad to catch, but I suggest that if you're looking to do things like this and do some exploit dissection, that you go ahead and get yourself a system that shows attacks being made. Snort is a great system. So this is käⱧ signing out here. Please post your questions there to InfoSec, because I know that you're going to have a few. There were a couple questions that were asked on the board of how to attackers get into your system to do this. Well, the question is not how they get in, but if you're running an exploitable version of software, they don't have to get in. They just have to send a fancy URL request to tell the system to do the attack for you, so they're not really in. That's a question that I think a lot of people are curious about. Like I said, please post your questions. This is käⱧ. Enjoy.